Hi everybody, and thanks for joining me. Today we're going to be talking about verifying trigonomic identities. So the beauty of these is that when you're working with trigonomic identities, what they want you to prove is that the left side equals the right side, all right? And there's all these different types of identities. So we have reciprocal identities, we have quotient identities, we have Pythagorean identities, and we have even and odd identities, all right? So what these identities actually mean is that this statement is true, okay? And so it gives you replacements. So for example, if you had 1 over the cosecant of x, you could replace it with the sine of x, right? And if you had 1 over the cosine of x, you could replace it with the secant of x. If you had sine over x over cosine of x, you could replace it with the tangent of x. So that's all really all of these things are doing, all right? And it's always great to make a copy or write down all of the identities that you know, okay? The other ones that are going to probably be the most important here are the Pythagorean theorem identities and the even odd identities. So let's first take a look at the Pythagorean identities. So the Pythagorean identities simply say that the sine squared plus the cosine squared equals 1. Now, if you look back or look forward at your unit circle or your knowledge of unit circles, remember your sine was your y value and your cosine was your x value. So you really have y squared plus x squared, or if I reverse the order, x squared plus y squared equals 1, which is a circle or the unit circle, all right? Then we can take this function and we can divide everything by sine squared. If we do that, sine squared over sine squared is 1. Cosine squared over sine squared is tangent, according to the quotient identities. And 1 over sine squared is secant. Let me try that again. 1 over sine squared is secant squared. Okay, so in this one, wait, go back. If I divide these all by the cosine squared, right, then I would get 1 plus tangent squared equals secant squared. And if I divide it by the sine squared, then I would get this. Sorry about that. And even and odd properties. So if I see something that says sine of negative x, I know it's equal to the negative sine of x. So you may not memorize these. You may not have to. Some may just be easy to recall, but it's always good to have a printout of this sheet, especially when you're working on it. So let's move to this guidelines for verifying trigonomic identities. So this is a whole lot of words, right? And of course, this will be posted. But what it basically says is you're going to work on basically one side of the equation and transform it so it looks like the other side. It doesn't normally matter whether you pick the left or the right. You want to pick, however, the complicated side to make it look like the simple side, right? So if you had some expression and it was equal to, let's say, the cosine squared of x, then you would want to work on the left-hand side because the cosines, it's hard to make something simple look difficult. It's easier to make something look difficult, take something that's difficult and make it look easy, all right? And then we're going to have a couple of things at our disposal. We can factor, we can separate terms, we can combine terms, and we can multiply numerator and denominators by things, all right? And this is really important. Sometimes you get on a tangent, and excuse the pun, and you can't get back. So sometimes it's easier to stop and start again. A lot of this is going to be about looking at puzzles and seeing it. And sometimes it takes you a few minutes to see it. And then sometimes if you can't see it, try something, right? Try some relationship that you know, but you're working on one side of the equation. So with all that talk, let's take a look at some of these problems. All right, so let's look at rewriting the identity secant squared plus cotangent x, I'm sorry, secant x plus cotangent x equals cosecant side. All right, so which side is more complicated? Well, it's definitely this side is more complicated. So I like to apply the reciprocal identity. So in other words, the secant is 1 over the cosine, and the cotangent is cosine over sine. So isn't that cool now when we rewrite that the cosine crosses out, and I'm left with 1 over sine x, and that equals cosecant x. All right? So that was a use of applying a reciprocal identity. Let's try another one. Let's take something different and do the same thing, apply a reciprocal identity. So I'm going to take this more complicated side, the cosecant x tangent x equals secant x. And I'm going to leave my right side alone. I'm not going to redo it into anything. You want to work on one side. So I can write cosecant as 1 over the sine. The tangent is sine over cosine. And now look, my sines cross out. And I'm left with 1 over the cosecant x, which is secant x. Okay? So remember, you're only working on one side. What will happen is if you work on two, like let's say you change this to 1 over the cosine, you know, sometimes it will become so complicated and so crazy. You just want to prove one side equals the other side. All right, so we're going to do a lot in this section. So let's look at a tip. Verifying that an equation is an identity is different from solving an equation. That's so true, and that's why we're leaving one side. You do not verify an identity by adding, subtracting, multiplying, or dividing each side by the same expression. All right, so this is not like the addition property of equality where we add to both sides, or the multiplication where we multiply something by sides. It's really, you have to prove that statement true, so you want to prove one side is equal to the other. Now, on one side, you can do a couple things, right? You can do a lot to one side, however, right? But you don't want to ever multiply it by like a single scale like 3. Scalar, sorry, like 3. All right, so let's do a few. So now we have the sine x tangent x plus cosine x is secant x. So first we want to decide which one is more complicated. Well, definitely the left-hand side is more complicated. So let's try a few substitutions. Let's try some quotient identities. So the sine x tangent x, well, look how we can take the tangent x and do sine over cosine plus the cosine x. Well, what's fun about that is we are able to now get a multiplication of sine x cosine x. So at least now I'm only dealing with two different things. And what's interesting is if you notice, I may be able to make common denominators between that. Okay? So this is when your algebra has to be tip-top. So if I move on to where I am, if I make this cosine x, cosine squared x over x, right? I'm just going to multiply. I'm going to make this a common denominator, so that's why this is cosine x. And I have sine squared plus cosine squared x all over cosine x. Now, what does that remind you of? Well, that really reminds me of the Pythagorean theorem, the Pythagorean identity, correct? So now if I take those, remember, the PowerPoints are in your Canvas to download. Now when I add them together, I'm going to get 1 over cosine x. And what's 1 over cosine x? Secant x. Correct. So when I continue this problem, I'm going to get that to be my secant x. I didn't do anything to the right side. I only messed with the left side. I applied a quotient identity. I applied making common denominators. I applied a Pythagorean identity, correct. And then I was able to do another reciprocal, another identity. All right, so those are the types of problems that you're going to see. And remember, they can be complicated, they can be simple, they can look crazy and end up being really easy to do. So let's take a look at this. What's our first question? Which side are we going to deal with? So we're going to deal with the left-hand side. And I'm not a fan of that cotangent, so I'm going to get rid of that to be cosine over sine plus sine x. I'm going to do the multiplication out. I'm going to do some math. So I have cosine squared x over sine x plus sine x. Now I can do that common denominator one. That's exactly like what we did in the other one, right? So that ends up to be cosine squared sine x squared. And look at that. That's a Pythagorean identity. So very, very similar to the last one. I'm able to reduce that numerator to a 1 over sine x. And what is 1 over sine x? Cosecant x. So it should be a pretty natural flow for you. All right, let's try another one. They take a little bit of work. They take a little bit of patience. They take a little bit of recognizing and knowing the identities, but it's not out of the realm of things. All right. So again, we have cosine cubed on the right, and to me that's not as complicated as cosine minus cosine x sine squared x. And what's interesting about that one is I'm going to do the left-hand side, and the first thing I think of is, okay, there's really nothing I can replace it with, right? But I've got to get this idea of cosine cubed on the left-hand side, and both terms have a cosine x. So if I take that out, I get cosine x times 1 minus sine squared x. And notice this is that Pythagorean identity. Remember, my Pythagorean theorem is sine squared plus cosine squared equals 1. But I can manipulate that to be 1 minus sine squared if I want a cosine squared. And I can manipulate it also if I needed a sine squared, right? It's going to be 1 minus cosine squared. So here I pull out the cosine squared, and what am I left with? 1 minus my sine squared. So be very careful when you're factoring that you don't make it go away. Imagine sometimes that they're just a big x or just a big variable. And now I'd have my cosine x times cosine squared x equals my cosine cubed. All right. So when I look at that problem, both the left and the right-hand side, I use some factoring. I use some Pythagorean identities, right? So I use that greatest common factor. All right, let's take a look at another one that uses the same exact principle, right? But in this case, my sine cubed, I'm going to be able to factor out a sine x, get my 1 minus my cosine squared here. Now I can pull out a sine, so I get sine x times 1 minus cosine squared x, and we already know that that was sine squared, right? Very, very similar. So it's a combination of what's going on in your algebra world and what's going on in your trigonometric world, correct? And when you enter calculus or you do a calculus course, you'll find that these substitutions are going to be really, really important, especially when you're trying to find the derivative, not so much, but maybe an integral or the antiderivative. All right, so let's look at this problem. 1 plus sine theta over cosine theta equals secant theta plus tangent theta. Well, I agree. I could probably go either way on this one. I might have started with the right-hand side. But let's look at what they did. To me, the right-hand side is more complicated than the other side. But what I'm looking at is I'm looking at that 1 plus sine theta. Well, remember in algebra, that's a combination of two terms. That's the combination of 1 over cosine theta plus sine theta over cosine theta. Well, I know sine over cosine is tangent, and I know that 1 over cosine is secant theta. So it might have been easier to do it on the left-hand side, okay? You could have done on the right-hand side too. If you looked at secant theta as 1 over cosine theta and tangent theta over sine over cosine theta, then you could have added the terms, right, because you have common denominators, to 1 plus sine theta. So there's not always, it depends what your eye sees as difficult and what somebody else's eye sees as difficult. So we could do the same very similar thing, right? But we're seeing the 1 over sine theta is cosecant, and the cosine over sine theta is cotangent. And it's very important that you understand that this is a combination of 1 over sine theta plus cosine theta over sine theta, right? So you've got to sort of recognize those kind of ideas. All right. So let's look at another one. Well, I'm looking at this one and saying, oh my. So I have, what do I want to deal with and what do I don't want to deal with? And you can't say I don't want to deal with the problem. That's okay sometimes. Well, what's interesting about this is I'm definitely going to pick the left-hand side because the only thing I know about the right-hand side for the secant is 1 over cosine theta. So really, all it does, or 1 over cosine x. So really, I only get 2 over cosine x, and that doesn't look like anything I have on the left-hand side. So I'm definitely going to look at the right-hand side of this. And I don't have any Pythagorean identities I can use. I don't see any square terms. But what I could do is add the two fractions. So I need a common denominator of 1 plus sine x quantity times cosine x, right? So that would mean I'd have to multiply my cosine x by cosine x, and my 1 plus sine x times my 1 plus sine x. Am I happy with it? I don't know. Let's see. You have to take a leap of faith. All right. So I have this, and I have to multiply the top. So I'm not going to multiply the bottom. All right. I'm just going to look at the bottom for a minute. See if I can get some kind of identity. And sometimes on this idea of, hey, I've got to, not doing some of the multiplication might cross things out. All right. But we have to do the multiplication on the numerator, but maybe not on the denominator. So let's just wait. So we have cosine squared plus 1 plus sine x plus sine squared x. Well, when I put it all on one line, right, and then let me see what I can add. Well, isn't that interesting? I have that 1 plus sine 2 sine x, right, similar. And I have a cosine squared x and a sine squared x. So that's looking really, really good to combine. All right. So if I take my cosine squared x and my sine squared x, I get 1. And I'm left with 1 plus 2 sine x. Okay, still haven't done the math in the denominator. So now I look at it and I'm like, oh, look, I can add 2 plus 2 sine x. So here I am at 2 plus 2 sine x. And I can factor out a 2 there, can't I? To get 1 plus sine x. Right? And then look at that. That's going to cross out. If I had multiplied that, I would not have seen that being able to cross out. So that's what you're kind of looking for, those opportunities to not do work, because it may cross out. And normally something that's complicated will probably cross out. So now I can cross out those 1 plus sine x and 1 plus sine x. And I'm left with 2 over cosine x. right? And what is when cosine x is in the denominator? So now I have 2 secant x. So what I thought was going to be like super duper complicated, the beauty of it is by not doing some of the math, and normally that will occur in the denominator. So when you're combining denominator terms to create a common denominator, don't multiply it out. Multiply your numerator out, but kind of a rule of thumb is not to do that on the bottom, on the denominator. All right, so we've gone over a lot. Let's do a few more, just a few more. All right, or maybe one really long one. But so now we have to verify the denominator. What do people want to do automatically? Oh, I just multiply and then I find them equal. That's fun, but not allowed. Okay, you need to pick one side. All right, so another option available to me, right? Because you would have gotten sine squared and you would have gotten one, and you would have found an answer and you would have verified it, but that's true. But remember, you can only deal with one side. So I'm going to deal with this side. And what I'm going to try to do is remember multiplying by the conjugate gets rid of some terms, right? Gets rid of that middle term, but still leaves us with the first and last term. All right, and sorry. Whatever you multiply the numerator by, you have to multiply the denominator by. This is not the same as multiplying the left by something and multiplying the right by something. Really, this value is 1. So when I multiply that out, I got 1 minus cosine squared. Ooh, that's kind of cool, right? Because that reminds me of a Pythagorean identity. And then I'm left with the top. And look, if I didn't multiply that out, my signs will cross out. And I'm left with my 1 minus cosine x over sine x. So don't be quick to do that multiplication. Okay? Now, let's do some more complicated ones. And these use that even-odd property. So what do you know about that even-odd property? And I'll be honest, sometimes I struggle seeing the even-odd property. But I know that sine of negative x, when I do that as an even-odd, that's going to be sine of negative x is the opposite of sine x. So notice how this crosses out to tan x plus sine x. All right, just by using that even-odd property. Now I have an interesting thing occurring. I know that tangent x, and I see 1 plus cosine x. So I have several options to make. Well, I could look for multiplying it by the conjugate, right? But I don't know if that's going to give me anything now. So I might think a little bit further and think about substituting tan x with sine over cosine x plus sine and see what that can do to me, right? Well, not apparent so far. I have to get to this idea of what was my original one, that it equals tan x, right? And I've gotten a little far. Well, what if instead of multiplying by the conjugate, I was able to add these together with a common denominator? I could go that route, right? And then I have sine squared x cosine x over cosine x, which is 1 plus over 1 plus cosine x. Well, let's see. I don't know. Might get me further. Let's try a little bit more. So then I would have sine x plus sine x cosine x. Oh, you know what's kind of interesting here? Even though I have my complex fraction here, look what happens if I pull out a sine x. I'm going to get my 1 plus cosine x. And then look, I see a tangent value in there. So let's look at that. So if, remember, dividing by 1 plus cosine x is multiplying by the reciprocal. And I do that a lot for my complex numbers. I just like to make sure I'm in the right value. So I did end up with cosine times 1 plus cosine x, but I'd really like to cross that out there and just end up with sine over cosine. So a little bit more algebra, okay? Now when I pull my sine x, I have 1 plus cosine x, 1 plus cosine x. So there's my sine x over cosine x. And then, now I have sine over cosine, and that was equal to my tangent. Now that's not only the only solution. All right, there are different ways to go through different problems and different structures of something problems. So sometimes you just have to, when it's not working out, is just ball up that piece of paper, wait 5 minutes and start again. Try a different method. Check your math, check your identities. You know, check those kind of things that are really going to help you rather than hurt you. All right, so learn those fundamental identities. In other words, either have them a piece of paper out there, print it out, write it out in your notebook. All right, rewrite the more complicated side of the equation. All right, it's easier to get from complicated to simple. Sometimes you can't decide which one to do because both sides are really complicated, but it just pick a side and go for it. And if that side didn't work when you're working for it, then stop that side and pick the other side. You want to keep your terms simple. You want to know some factoring, right? You want to keep your substitutes reaching towards your goal. So if you're trying to get to tangent, I'm not so sure I would substitute cosine with 1 over the secant, because that's not going to get me to something simpler. All right. Don't forget about conjugates. Don't forget about adding like fractions. You might have to make it a like fraction, right? And give yourself plenty of room when you're writing your workout. There's no reason that you have to scrunch everything together. All righty. Thanks so much for joining me. Have a great day.